Hello friends, myself Rajendra Mahajan presenting my video on linear differential equation. Let us solve the problem. D cube plus 2d square plus d into y is equal to e raised to 2x into x square. If we see the left hand side, it is a cubic equation, and on right hand side we have e raised to 2x into x square. Its type is e raised to ax into v. What is v here? V is here x square, and therefore to solve it we have to obtain the complementary function and pi. Therefore watch the video up to end for better understanding, clear understanding. A given differential equation is d cube plus 2d square plus d into y is equal to e raised to 2x into x square. Then we write down the auxiliary equation. Auxiliary equation means the equation in terms of d. Therefore, it is d cube plus 2d square plus d, and we equate it to d common from it. We get d into d square plus 2d plus 1 equal to 0, and therefore first factor equal to 0, d equal to 0, and second d square plus 2d plus 1 equals to 0. This d square plus 2d plus 1 is a perfect square of d plus 1 whole square equated to 0, and therefore we have the roots. First one d equal to 0, second one d is equals to minus 1, and third again minus 1. Therefore there are three roots. First one is real and different, and remaining two are real and repeated, and therefore we write down complementary function CF as a combination of two cases. For that distinct real root we write down as C1 e raised to 0x means 1, and for this repeated root it is C2 plus C3x multiplied by e raised to minus x. Equation number, or we can rewrite that once again as C1 plus C2 plus C3x multiplied by e raised to minus x, and we call this equation 1. In next part we try to find out the pi part. Pi is given by inverse operator 1 upon d cube plus 2d square plus d, which we have to operate on e raised to 2x into x square, and as it we have to replace d by d plus a. A is here 2, and therefore replacing d by d plus 2, it is we have to take e raised to 2x before the operator, outside that operator, and 1 upon replacing d everywhere by d plus 2, it becomes d plus 2 cube plus 2 times d plus 2 whole square and plus d plus 2, which we have to operate on x square, and then expanding each and every bracket we get 1 upon. The first one is a plus b whole cube. Its expansion is a cube, means here it is d cube plus 3d square, b is 2 plus 3ab square, 3d and b square means 2 square, plus b cube, 2 cube, that is 8. Then plus 2 times expansion of that term d plus 2 whole square is d square plus 2 to the 4d plus 2 square 4, and plus that d plus 2 remaining term, and which we have to operate on x square. Then simplifying it further, e raised to 2x as it is 1 upon adding the similar terms, d cube only one term, therefore we write down that as it is d cube, 3 to the 6d square plus 4d square, 2d square, 6 plus 2 we get 8d square. Next 2 square is 4, 4 3 is 12, 12d plus 8d, 12 plus 8 20 and plus d, therefore it is 21d. Next constant terms, 8 plus 8 16, 16 plus 2 that is 18, which we have to operate on x square. And then as we are operating it on x square, we have to take the lowest degree term as a common from all this, and here the lowest degree term is 18. Therefore taking that as a common, we get e raised to 2x divided by 18, 1 upon. Remaining terms we write down in the form of 1 plus or 1 minus. Therefore here it is, when we take 18 common from 18, we get 1. Next one is 21 by 18 times d. Next 8 by 18 d square, and then neglecting the term of d cube, as the power of x is 2, means we have to consider the terms up to d square only, and that's why I am neglecting this term of d cube, and then operate it on x square. Then transferring this term to numerator, we get e raised to 2x divided by 18, 1 plus remaining terms are 21 by 18 times d plus 8 by 18 times d square and whole raised to minus 1 and operate it on x square. Then expanding this bracket by binomial theorem. Expanding by binomial theorem, up to terms containing d square, up to terms containing d square only, means we have to neglect d cube, d raised to 4 and higher order terms, as all the derivatives of x square becomes 0 for d cube and higher order. 1 plus capital X raised to minus 1, terms alternately positive negative, 1 then minus x, then plus x square, then minus x cube, and so on. Therefore this is the sub-result of binomial theorem, or the result obtained using binomial theorem. Expanding by binomial theorem up to terms containing d square. Therefore it is by the formula 1 plus capital X. This complete term we consider as capital X and whole raised to minus 1. Its expansion is 1 minus x plus x square minus x cube, and so on. Terms alternately positive negative, and therefore e raised to 2x by 18 as it is, no change. First term is 1, next is minus x, means minus in bracket 21 by 18 d plus 8 by 18 d square, then square of it, therefore it becomes 21 by 18 d plus 8 by 18 d square, and this square of that bracket, and so on. And then simplifying it, its expansion as e raised to 2x by 18, no change. First term 1, multiplying by minus inside, we get 21 by 18 times d. Next, minus 8 by 18 d square. Then expanding this bracket by a plus b whole square. The first term is a square, means it is 21 by 18 square and d square. Twice ab, it become d cube, neglecting that terms of d cube. B square means it become d raised to 4, neglecting that term also. Means we take only one term from that expansion, and that term is 21 by 18 whole square into d square. And then we have to operate on x square. Then multiplying inside or operating that terms of d on that x square, we get e raised to 2x by 18, no change. 1 into x square, we get x square, minus 21 by 18. D of means derivative of x square, first derivative is 2x, minus 8 by 18. Second derivative of x square is 2, plus 21 by 18 whole square. Second derivative of x square is again 2, and bracket close. Further simplification, e raised to 2x by 18, no change. X square we keep as it is. Dividing by 2, we get minus 21 by 9 times x. Then dividing by 2 here also, minus 8 by 9 and plus 21 square by 18 square into 2. And we call this equation number 2 as a PI. Then we write down the complete solution, final solution, as sum of CF and PI, CF plus PI. And complete solution is always for the dependent variable. Here the dependent variable is y. CF is C1 plus C2 plus C3x and e raised to minus x. This is the CF, equation number 1. Then PI plus e raised to 2x by 18 multiplied by the terms inside the bracket are x square minus 21 by 9 times x minus 8 by 9 and (21 by 18) square into 2. Into 2. This is the required solution or required answer. Therefore, watch the video once again from the beginning up to this last step. If you like my video, please share it, as well as subscribe to my channel, and to receive the notification for such type of new videos, please press the bell icon. Thank you. Thanks for watching.